As we said earlier in the day, this is actually failure as success, the mindset, the methods, and the landmines. It's a good, so if you were wanting to hear the whispers and chaos talk, we're actually going to be talking about a lot of the same things. So you're gonna kind of have the same, you're going to hear the same stuff. This is also a good follow-up to Russ's talk this morning, because he was talking a lot about chaos engineering. So this actually is talking about failure, how you think about it, and kind of different ways you might think about it in your organization, which is also kind of a lot of what Russ was talking about. So hopefully this works. Yes. Okay. So I wanted to start actually with a quick survey. How many of you are, how many of you run postmortems when you have an incident or an outage? Okay, good. So about half the room, okay? And then how many of you are responsible for running those postmortems? Like you actually are the person there that's, okay, a couple hands. Yeah, okay. Okay, about 5 people. How many of you attend the postmortems? Okay, and then how many of you consume the output of a postmortem or a retro? So it's pretty much everyone in the room. So that's really good. So the second thing I want to start with is for our session today, I want everybody to buddy up with someone. So get a buddy, teams of 2, but no more than 3. So introduce yourself to whoever you're sitting next to. Say hi. Teams of 2 or 3, but no more than 3. Do we all have a buddy? This is a good presentation to end the day with, right? We all get to say hi to everyone. Okay. Do we all have a buddy? Okay, perfect. Now, what I want you to discuss with your buddy is we need one person to be the A person and one person to be the B person. So decide on who's going to be which right now. Got that all figured out? Okay. And now that we have that, figure out the last bit of logistics is you're going to need some paper. Okay? Now, wait a minute. Wait. If you have paper, go ahead and get it. If you don't have paper, we've got pads. I'll actually put them there. Who needs some paper? I should just throw this at the audience here. Why don't you pass that down? Pass that over there. Pass this over here. Okay. Does everyone... There's some pads making. So grab right there. Right there. Here. And you're only going to need 1 or 2 sheets of paper. So if people still need a pad, go ahead and pass the pad. Who needs a pen? Now this I could just throw out like I just did. Everyone needs a pen. 2 pens. Yeah, you need your own pen. All right. Let me know if we need more pens because I have these colorful pens if we need more. Do we need more? Did we run out? There's some making their way back there. Whoa. Okay, I'm going to put these here in case anybody needs them. Okay. So, the great thing about this talk is you've seen, the next slide is talking about, the talk that you saw this morning. So I don't need to talk about it because you've seen that talk. Now, but what I do want to do is I want to start with a thought experiment that's sort of based on that talk. And so we talked about this idea of developers as the pilots, right? And the air traffic controllers as the ops people and what that might look like and what we could take from that. So I want to start today's talk or this talk with a thought experiment and this idea of an incident in what we might call the JFK data center, right? So this is an actual recording between a pilot and an air traffic controller at JFK Tower. And I'm going to tell you right now, I will ask you questions later about what you're about to see. All right, let's see what happens here.
Larger 200 carry channel and 220, number 2 for the field, traffic on a 4-mile final at 3 on right, wind is 320 at 22, clear the line on the way 22 up. Larger 2 heavy, 22 up, do you clear the line? Clear the line. You're local, not mine. Okay, I will double check it. American 2 Heavy will just reset it. Should be coming back up in a little while. Wing now 32023, that's in the 35.
We can't land on that we're breaking off the truck, and you don't give it to runway 31 right in front of declare emergency.
I'll put it along, fly runway handed for now.
Okay, declare emergency. Go in 31 right, front to the left, and it's coming around.
American 2 Heavy, just fly runway handed.
They're in the area.
Okay, you say you declare an emergency at 6?
3 times I've told you that. 3 times we're declaring an emergency.
Okay, I just want to verify. I know you told me if you didn't get 31 right, you would have to declare an emergency. Okay, I understand. Fly runway handed. I got to get you a turn.
No.
Get with 62, the left side alpha and monitor ground to the ramp.
That's alpha on the ground.
I headed 180.
You know, American 2 Heavy, we are turning around to the left here and landing on 3-1. Remove everybody from our way. We've declared an emergency.
All right, so let's pause on that. This sounds pretty stressful, doesn't it? If you've ever flown into JFK, this might make you think twice about selecting JFK as your destination. But so I have a question for all of you. Was this event a success or a failure? Depends. Why does it depend? If they land. Now that's interesting. That's an interesting way of looking at it. So we're going to talk about that and why, because that, by the way, that comes up all the time. People ask, well, okay, what happened, right? So we're going to look at that a little bit. All right. And in fact, in my speaker notes, one of the notes is who wants to know if the plane landed, right? And raise your hand. Who wants to know if it landed? Okay. Yeah, that's what I thought. All right. But so come to think of it, right? When we ask this question, what is success? Right, to your point, is success just the absence of failure, or is it something else? And that's what we're going to be talking about today. So I am not going to go through this slide because you've seen this slide. One of the things that I really want us all to think about as we're talking about this today is when we talk about things like failure, a lot of how we think about it is going to be informed by our own feelings and experiences with failure. So what I mean by that is, if you were raised where if you got knocked off the horse and your parents said, hey, get back up on the horse and keep trying again, versus maybe you had parents like mine that said, maybe you should play the clarinet instead of riding horses, you're going to think about failure differently. Also, the type of organization that you work in, right? If you work in a big enterprise, maybe they might think of risk and failure a little differently than a two-person startup might think of risk and failure, right? So I only call that out not to say that any way that you might think or feel about it is right or wrong. It's just when we talk about this stuff, it's good to sort of think about those things. And that'll factor into how we think about it. One of the things that is very interesting, and this is just Google search results for chefs' postmortems. There are a lot of organizations that are starting to do their postmortems in public. Chef actually does their postmortems on a Google Hangout. They actually hold the meeting on a Google Hangout, and then they post the results on their website. So for those of you that do operational and incident retrospectives or postmortems, you might think, like, would you want to do that? Would you want to hold that on a Google Hangout? And if not, why not? You see a lot of this idea of like blameless postmortems, and everybody's happy and yay about it. Who's heard the term blameless postmortem? Okay, who feels like that today? Who feels like that term is weird? Like it just seems weird. Yeah, by the way, I won't blame you if it seems weird. So the other weird thing that you see sort of in our industry, and at least we see it a lot in sort of the press about the technology industry, is this failure fetish in Silicon Valley, right, where I am, or the startup failure craze, and this kind of like thinking about, oh well, it's a startup and we pivoted. We didn't fail. We didn't lose all of our investors' money. We pivoted, right? The problem with entrepreneurs' failure fetish. I kind of like this because it's like this developer's sitting looking sadly at how his startup failed or whatever. Or maybe he's just sad that he's paying $5,000 a month for an apartment in San Francisco. So today we're going to talk about all of these ideas, and we're going to go through the mindset. So how to start thinking about failure as potentially a success, or at least not a bad thing. We're going to go through the methods. So these are the things that you would need to do in your organization if you wanted to start talking about that. And then we're going to end with the landmines. And these are some of the problems that I see organizations running into when they actually try to do this. Because it's not easy. It's kind of a deliberate process, and it takes some work. All right, so let's start with the mindset. So we're going to be talking about a lot. You'll hear these words a lot today: incident, success, retro, blame, accident, right? But really, human error is another big one. But really, we're talking about, in some sense, this idea of safety, right? And we're going to be looking at a lot of the safety science research that's been done over the past 75 years in all sorts of industries that have very little actually to do with IT and technology until they started looking at that, and that became an area of interest for research in probably only the last 5 years. But we're talking aviation, nuclear, those sorts of industries have been looking this for a lot longer. You might think to yourself, well, okay, why do we care about this in technology, right? I get why we care about it in aviation or nuclear, but why do we care about it in technology? And I have a question. Who has heard of Knight Capital? Anyone heard of Knight Capital? All right. Knight Capital was an organization that was a high-frequency trading organization. They did a deployment on a Wednesday. They had 8 servers, and they did a deployment on a Wednesday. They opened up for trading on a Thursday morning, and they had done the deployment. They'd forgotten a couple steps in the deployment, and they got themselves into a trading situation where they were losing $140,000 a second for 45 minutes. When it was said and done, they lost $480 million. That was Thursday at 9:45 a.m. Friday morning, they're out of business. They didn't have the capital to cover the trades that they had made. So the reason I bring that up is because we're working in these complex systems, and it's not just about the complexity. It's actually about how quickly these systems can move and almost turn against us in some way, right? We're literally talking deployment Wednesday, bad day Thursday, we don't exist as a company Friday. Now, you might say, okay, well, we don't do high-frequency trading, so maybe I don't have that problem. This was an outage from the PetNet smart feeder. So it was this that they posted an article about it. So it was this pet feeder that you could get for your dog Fluffy or your cat Fifi. And it would allow you to put food in the feeder and then use like a smartphone app to like feed your animal on a schedule. And what I thought was interesting about this, they tweeted, there's some minor difficulties with a third-party server. Are they using a cloudy thing? Like, I don't know what that is supposed to mean. But basically, the upshot is, whatever this third-party server was, they were starving people's pets, right? They had some dependency on some system where it was causing a major outage, which means animals weren't eating, right? So one of the interesting things about this is, okay, maybe you aren't involved with feeding pets or animals, but the thing that I would point out is their excuse for this was something related to either cloud or some third party. So it's interesting for us to think about, like, who's doing any cloud stuff? Like, to start thinking about the way these things might interact in ways that we used to not even have to think about, but now we do. So what I want to start with is this idea. We're going to talk a little bit about how safety and the idea of safety has changed over the years in the safety sciences, and then we'll go through why that's applicable to the work that we do. So we really started thinking of safety as this concept of energy and barriers, right? And so failure, this idea of failure, is a release of energy, an uncontrolled release of energy. Now, if you want to control that, what would you do, right? you can design safety into the system by building more barriers, right? In fact, if you want more safety, what do? More barriers. This idea of defense in depth, right? If we just build more barriers, if we build a bigger containment on the nuclear reactor, everything's going to be fine. Now, this was a model that was started in the post-World War II era, and it worked at that time because a lot of the things that we were thinking about with respect to safety came from manufacturing. So you could literally look out on the factory floor and see products moving, you could see machines running, and you could sort of reason about, okay, well, where are the parts in the system that might be unsafe, right? Where there's big heavy machinery, that sort of thing, where maybe we're moving products from one station to another, so maybe there's like forklifts or things. But we could see that. And we could look at it and go, oh, okay, well, maybe that area is a little unsafe, so we want to do something, more training with our workers or something about that in that particular area. So this model worked relatively well for a long time, a number of decades, and then something happened. Something happened in the late 70s that turned all of this on its head. Anyone guesses? Three Mile Island, right? 3 Mile Island happened in 79. In fact, there were 3 incidents that happened late 70s, early 80s that turned this model on its head. 3 Mile Island started it. Can you guess the second one? Same industry. Chernobyl. Yep. Third one. Yep. Those are the 3 that made us all go, wait, this model of energy and barriers is not, it doesn't make sense anymore. It's not right. It doesn't work. And the reason that, so people started digging into this, right? Okay, what is going on here? And what they found is there were 2 things. Complexity of our systems was increasing. And the major component where that's relevant for us is in the 3 Mile Island case and a lot of the other cases that we mentioned, we don't have direct observability of the system. Right? I can't go into the reactor core and take the temperature. So we've got a system that does it, and there are relays that present to me the information, right? But I'm not directly looking at the system. I'm looking at a system that's looking at the system. And the problem is, what if the readings that I'm getting from that system, and you might have a backup, what if they disagree? Now, what does this sound like with monitoring and some of the complex architectures that we have in our computer systems, right? We're not often directly monitoring. We're looking at derivatives of monitoring data, right, and trying to figure out what's going on. So that was an issue. The other thing is that we started scaling these systems in ways that they've never been scaled before. So if you know anything about nuclear power in the United States, the history of it is basically the power plants were submarine reactors that we made really big, and then we bolted a generator onto it. And we thought, well, if you just scale it, and then you scale the barriers with it, it'll be fine. But you started getting these emergent behaviors when we do that, and that's what really bit us here. Now, you mentioned what happened in the 70s, computers was a thing. I'll point out a funny story about that. So 3 Mile Island did have a computer that was pretty advanced for its day. It had one of those big dot matrix line printers, right, that they used actually as log stuff. So it would print out when events happened in the plant, right, and then they would be able to have a paper record of what happened. When 3 Mile Island happened, about 8 or 9 hours into the incident, they finally just rebooted the computer. The printer had been printing for the last 8 hours. When they went back and looked at the paper record, it took the computer 8 hours to print out the first 5 minutes of that incident. So this goes back to that idea of we are building these complex systems, even back then, that are so quickly moving. Some of the technology that we built around it may not actually be able to keep up with how quickly the situation is actually changing. So as part of this, when we started thinking about this, there became this kind of idea by a guy named Charles Perrow of normal accidents. Charles Perrow was a sociologist too. And he says that you actually can't have safety because you're just going to have these normal accidents. And what he modeled was on an axis. One of them was degree of linearity versus complexity. So is our system very linear or is it very complex, right? The other axis was degree of system coupling. So how tightly coupled are the components of our system? If I perturb one of them, is that perturbation going to be pushed to the next one? Or are there buffers there where there's some slack space? Those were the 2 degrees that he mapped this stuff on. And his hypothesis was certain systems, the complex and tightly coupled ones, are going to just have accidents. And also, this is where the name comes from, that's normal and actually just unavoidable. There's no way you can design that out of the system if you have a complex, tightly coupled system. So this is out of his book. And so you'll see loosely coupled down here, tightly coupled up here, linear over here, complex over here. So it's interesting to see some of the things that he put on here. Loosely coupled, but more complex are like universities. I also like military adventures are over here for some reason. Single goal agencies. So they're loosely coupled and they're fairly linear. So those are things like the post office, the Department of Motor Vehicles, that sort of thing. Dams are fairly simple. They're linear, but they're tightly coupled. What did he mean by that? Well, we all kind of understand, at least at a conceptual level, how a dam works, right? It's bricks and it's holding water back, right? But if you take one of the bricks or there starts to be a crack in the dam, right? Because it's so tightly coupled, that dam will break in those situations. And I don't know if you probably didn't hear about the Oroville Dam crisis, which was a dam in California that was starting to break because of a lot of rain. And so this actually example was very recent that happened this summer, and the entire state was trying to pay attention to like what's going on with the Oroville Dam. Pero was mostly concerned about complex, tightly coupled, right? So up in this corner. And you'll notice nuclear plants are way up there, nuclear weapons accidents. And that's really what he was concerned about. So that's normal accident theory, is what it's called. Finally, there were a group of researchers at Berkeley, and they were looking at systems where normal accident theory, they were complex systems, tightly coupled, but they weren't seeing accidents at the rate that we would assume that you would see accidents, given this. And they were like, that's really odd. What's going on there? So they started studying what they called high reliability organizations. And they studied a bunch of different ones, but the coolest one is they studied the decks of aircraft carriers and the operations, landing planes on an aircraft carrier, what that's like. And so what they found is there's constant active learning going on, right? And so they put the officers and the people on the deck of the ship, they're constantly doing training, and they're constantly learning about the tasks that are happening around them and the job that they need to perform. Part of that is they rotate the crew through. So when they did the interviews, they found that they basically only let the crew do the job for about 6 weeks, and then they move them to the next thing that's still on the deck of the carrier, but it's some other task. And what's interesting about that, a bunch of quotes were like, as soon as I feel like I know my job and I know it really well, I'm off to the next thing. But of course, because they were in the Navy, the officers and the people on the deck just dealt with that. This is one of the big ones, decentralized active review. So what that means is on the deck of the ship, as I'm doing my job, I'm looking around to all the other people and just making sure, hey, does everything look right? Are they doing their job, but did they potentially miss something, right? Did they forget to reset the hook for the plane or whatever it might be? Now, these first two fit into that because if I'm supposed to sort of monitor you kind of out of the corner of my eye, but I don't know what you do, then I can't do that. Right? So that's why they did that rotation and training. So I kind of know the entire system and when the operations are normal on the deck of the carrier, I have a sense of what that feels like. Rank is de-emphasized, oddly, because you think it's the military, so that matters. And of course it does. But what they found is the lowest ranked person on the deck of the ship could say, we're not landing aircraft anymore. And they would say, okay, we'll stop landing aircraft, and then they would go solve that problem. But it wasn't this command control thing that you might expect, which that actually really surprised them. And this is probably the most important, especially for what we're talking about today. Success may, in fact, be failure. What do I mean by that? Well, they could have a landing on the deck of the ship, and the plane could pull off in its parking spot, and the pilot could get out. And everyone involved on the deck of the ship could have considered that a failure, even though for us or an admiral looking at the situation, you didn't dent the plane, you didn't dent the boat, and you didn't dent the pilot. So what's wrong? But everyone in the system was like, nah, that didn't feel right, the entire process of that entire landing. It just didn't feel right. So they would treat that success as a failure and look at it just as stringently as they would had it been an actual crash or a failure. All right, so recap on these three theories, and then we're going to look at how they have unfolded in technology. So we've got energy barriers, we've got normal accidents, we've got high reliability organizations. The shift that you see between these is you've got static processes and repeated defenses, moving to more active defenses and processes, right? So rules and processes and regulations and barriers to actually people actively looking at what's going on in the system. Again, barriers, so technical engineering solutions, right? We can design safety in if we just design our system better. To actually solutions inherent to the people, the organization, and probably most importantly, the way that people do their work. That was the big shift. So if you look at this and we apply it to technology, we've done this as well, maybe without knowing it. We have backup. Who remembers like having to go to the DR site, right, and kick the tape drive or whatever it might be, right? We used to have backups, redundancy, multiple disaster recovery sites. That's how we solved the problem. Now we see a lot of simplifying and decomposing. So in other words, trying to make our systems less complex, not necessarily linear, but just less complex, and then decoupling them, right? That's what microservices actually are about, right? Also, anybody ever code COM or Corba? Right? If we had, for those of you, COM stands for Component Object Model. The idea was if we build these components and then test them, we can reuse them, but we can decouple the components. If you work on a monolith, right, you're trying to get away from that, and that's that thinking, right? And then finally, to high reliability organizations, we're seeing those do drilled incident response. So that's some of the chaos engineering that we talked about this morning, retrospectives, red teaming, and an idea of value streams, which I mentioned earlier. Do people know when I say red teaming, do you know what I mean by that? Okay. Red teaming is where you hire someone to, usually it's in a security context, to hack you. You pay them, and they're like, go hack the entire company. All day, every day, that's your job. It's in the context of red teaming and blue teaming. So red team is the attackers, and blue team are the defenders, right? And banks do this. Well, banks are starting to do this. I know a number of big software companies. In fact, I think I can say their name because they've done presentations on it. So Intuit, who does tax stuff in the United States, they have a red team, and their entire job is to go hack Intuit all day long. And it's funny if you watch a presentation how they talk about how they talk to their legal department to get the permission to do that, because you're potentially talking about exposing, customer data and things like that. And so even if you're employed by them, you got to think about, because you're technically sort of breaking the law. All right, so the methods, failure, success, the methods. Let's talk about that. So injecting failure. What's interesting is we talked a lot about that. Russ talked a lot about that this morning. Of course, going to talk, Chaos Monkey. So show of hands, who's heard of Chaos Monkey? Okay, pretty much everyone. Okay, cool. So I'm not going to go over it. The one thing that I'll mention about it that I think is interesting is we talk a lot about the monkey, Chaos Monkey, but they do have a simian army. And so they have a conformity monkey. Let's see, conformity monkey, latency monkey, security monkey, janitor monkey. They have other monkeys, and they do other things. Conformance monkey actually goes through and sees if all of the instances comply to some of the best practices that Netflix has come up with for their Amazon images, right? So it's not, we always talk about Chaos Monkey or Chaos Kong because they're kind of interesting. And also, I guess they're the ones with the guns. But there are other monkeys. The other thing that you are starting to see people doing in terms of chaos is like human chaos monkeys. So the idea there is I come up to you on a Thursday and I say, give me your VPN fob, give me your laptop, give me your cell phone, your company cell phone, go home. I don't want you answering any email from anyone or text from anyone. And then on Friday, you go run a drill. Because then you're going to find out what you know and what nobody else on the team knows when we run that drill. It's also a popular one because then people get 4-day weekends for free. But you are starting to see people doing that. You're also starting to see like hardware chaos monkeys. So what I mean by that is they will see somebody. So you work on a Mac. What they'll do is take your Mac and give you a Windows laptop and say, all right, run an incident or work an incident that's a game incident, but with a Windows PC or Windows laptop. Why? Well, because we store all of our SSH keys and our GPG keys and all our credentials and all of our login notes on our laptops. Well, what if that gets stolen out of our car while we're on call on a Friday, right? So they drill the people side of these systems and introduce chaos in somewhat controlled ways. It's not just about the chaos monkeys that go and shoot the instances, the Amazon instances in the head. So incident command and crews, you see a lot of organizations really starting to look at this. I mentioned this morning that there are firefighters that will teach IT people incident response, stuff that's been learned from the fire service. In fact, I work with a group that does that, and they're actually they're really interesting people, and they're also incredibly smart. One of them wrote like the hazmat book that's used for all of the fire departments in the U.S. And so then he'll also teach you incident response for IT stuff. Kind of interesting. One of the things that I want to talk about, so has anyone in the room had incident training or do incident like kind of training response at their organizations? Okay, I see one hand. So the one thing I'll mention about it I think is interesting. Our industry is getting really good at forming crews. So there's an incident, we come together, we work the incident, great, right? We're not so good at how do we then dissolve the crew in a way that makes sense. So here's the example I'll give you. Your house is on fire, call the fire department gets in the truck, they roll up, they put out the fire. We are getting better as an industry at that process. But where we aren't so good at what happens after that. And it would be like the fire department basically taking all their gear off on your front lawn, dropping it, leaving the hose out, and walking away, not driving the fire truck back. We don't do a very good job at getting ready for the next incident, putting the hoses away, getting our our gear back on the right hanger in the firehouse, backing the fire truck in as opposed to driving in so that when it's a fire, I don't have to like back the truck out, right? We're not there yet as an industry, and I think that's actually a frontier. If you get good at incident response and forming it, then also that how do you dissolve that crew in a reasonable way? Postmortems or blameless postmortems. We're actually going to talk a little bit about that. I asked earlier, blameless, does it seem weird or uncomfortable? If it does, you're not alone. This is another sociologist named Brené Brown. She's done research on vulnerability and familial interactions and things like that. And she has a great quote, blame is a way to discharge pain and discomfort. And what she means by that is humans are actually hardwired in our brains to use blame as a technique when something feels bad, like we can do to ourselves, right? How many people have said, oh, I didn't mean to type that command that took the site down? We're blaming ourselves. We can also use it to blame others. Like, now that's not my fault. That's that other team's fault, right? We're hardwired for that. So the thing that I always bring up that I find interesting, when you say blameless, it's like you're going to a meeting. We're going to have a blameless postmortem. You go to a meeting, and it's like, we're going to pretend that none of us have arms. Now, I can see your arms and I can see my arms, but we're going to just not talk about it and pretend they don't exist, right? So if it feels weird to you, that's why, because we're cognitively sort of wired for it. There's an interesting, there's some issues with this idea of blameless and postmortem. There's just some nascent discussion starting now around this idea of blame versus sanction. And so, in other words, blameless versus sanctionless postmortems. And the idea being that blame is the act of like, I'm blaming you, but maybe there's no sanction for blaming you. And so what we're basically finding is that actually it's not so much blameless as it is we're actually shooting for sanctionless. So in other words, the blame, there's a cause there, right? I'm blaming you for doing something. A lot of blameless postmortems, actually there is a root cause analysis in there, right? But we're actually talking about sanctionless. This is a very new thing that just came up literally in the past probably 9 to 12 months in the safety sciences, in IT, by the way. So it's a new idea, but you're probably going to hear more about it. Connotation of postmortem, right? So a lot of times people say, oh, I don't want to do a postmortem because nobody died, right? And it's like, well, yeah, we did lose $1 million, but nobody died, right? So this idea of blameless and postmortem can feel weird because postmortem also has a weird connotation. I think we're stuck with the term blameless postmortem, but I did write an article on this idea of blame aware. There's some nuance around that. So if you're kind of curious about this topic, you can read more about that there. All right, so how do we do postmortems? Well, one of the first things that's super important is to actually debrief the actors. There's lots of ways to do that, but it's really important that you, in some way, debrief the actors. And in some cases, a lot of organizations actually debrief them in different ways and do it multiple times. But that's critical, right, to do. You got to gather the data. So we've been talking a lot about metrics monitoring here at DevOpsCon. If you aren't doing monitoring, this is yet another area that monitoring can help you with. So you should be doing it. But you want to gather the data, right? And then once you do that, you can start to create a timeline, right? And there's different levels of timeline here, but this is an interesting one. This is out of the Field Guide to Understanding Human Error. It's a book by a researcher named Sidney Decker. And he's talking about, so this is where we talk about the data, the graph data from our monitoring metrics, right? And then what is really compelling, if people have heard of something called ChatOps, right, where we do all of our operations on our system via chatbot, it allows us to reconstruct this stuff. So what the tasks were, and then even down to what people actually said. Now, the reason this is useful, and the reason that if you can generate a timeline with this sort of fidelity, is because you start to get these vertical lines that are called events, kind of capital E events. And what they're trying to show is like, so this is the start of the incident, right? But what they're saying is, okay, well, these two people were doing something, and as they did something, well, okay, the graph went up, something clearly happened, and there's silence here. So was there supposed to be, would we expect that there would be silence there? Or should those people have been talking to each other? Now, maybe I don't know the answer, right? Maybe the silence is totally fine. But you'll notice here, right, these graphs peak and then they start to go down. And you'll notice, okay, there's people involved here and that you see it. That's kind of ominous, right? Or maybe it's not. That's the interesting thing about this. You don't actually know outside of context. But the point is you want to get these events because they're kind of the pivot points in the incident, and that's where you get a lot of meat about understanding what happened, but also how the team responded to what was going on. So what we're going to do is, for 5 minutes, I want you to create a timeline. That's why you have pad and paper. A timeline of the event that we saw at the beginning, the air traffic control and the pilot talking. Now, here's the thing. This is by yourself. So nobody talk to your partner, by yourself. Now, the other thing that I will say, for the B people, I want you to start at the beginning of the recording, the beginning of the incident, and I want you to do the timeline forward. For the A people, I want you to start at the last thing you remember and go backwards. Okay, so we'll do that for about 2 or 3 minutes. Write a timeline. No cheating. No comparing notes with your neighbor. Yes, I do not. Well, wait a minute. Yes, I do. There are these. We have these markers. You can pick whichever color you would like. All right. Anybody else need a pen? Yep. Oh. Would you like not a marker? Would you like an actual pen? Okay. We'll do this for about 1 more minute. Bless you. All right, 30 seconds. Get your last few events on your timeline. All right, set those aside. We're going to look at them again in a sec. All right, so the methods, retrospective, one of the last methods, retrospective ready infrastructure. So what I mean by this is basically this is our version of aviation's black boxes, right? You need to have the architecture of your application as well as the infrastructure on which it runs needs to be retrospective ready. Some examples of what I mean by that, I mentioned ChatOps. So if you don't know what ChatOps is, actually I'm going to show you a report you can download in the next slide, so get your cameras ready if you want to know more about ChatOps. Teammate is an interesting tool that you can use. If you have a server, you can, via Teammate, actually view the terminal with another person. This is especially good if you're co-located or have remote people. And so it's kind of this idea of like a pilot or a co-pilot where they can debug the problem together and they can see the same screen. And there's options where you can only let one person type or let both people type or whatever. But it allows sort of collaborative debugging during an incident. And then incident response and management tools. So a lot of tools these days actually have some, that do like paging and things like that, actually have an idea of at least creating an initial timeline for you to look at in a retrospective context. Here's a book on ChatOps. My friend Jason Hand wrote it, highly recommended if you want to know more about ChatOps. And there's a lot of actually interesting stuff going on in the ChatOps space. So I recommend you take a look at it. All right, failure as a success, the landmines. This is probably my favorite section. So organizational incompatibility. Some organizations are just going to struggle with this a bunch and this idea a bunch. And it's just sort of the way it is. I kind of referenced that at the beginning of the presentation. I don't want you to go back on Monday and walk into the data center of your company and start yanking out cables. And when someone says, what are you doing? Say, oh, this weird, crazy person from San Francisco said that we could be more stable if I just yanked stuff out of the wall. I don't want to get that email from any of your managers or executives. Have people heard of this book, The No Asshole Rule? This is a book by a professor at Stanford, a business professor, and he talks a lot about, basically how to deal with difficult people in your organization. He's done a lot of research on it. By the way, he comes up with a value called the total cost of asshole. It's the amount that an asshole costs per year in terms of your organization's time and effort. In case you're curious, it's $160,000. Anyway, he's got a great quote. The best single question for testing an organization character is, what happens when people make mistakes? Another landmine, only certain groups get to fail. So I always find it very interesting that when developers write bugs, which is a failure, that's writing a bug. But when operations people have a problem, like that's a failure, right? I was a build engineer for a long time, so I got lumped in with the ops people. Like if I made a mistake, it was a massive failure. But if the developers wrote a bug, it was just a bug, right? Not that I'm bitter about that at all. But if you have kind of this two-tiered system where certain people are allowed to fail and others aren't, that's going to be a landmine. That's a problem. This kind of idea that stopping the line is a privilege. So this is the Toyota production system. We talk about it a lot in DevOps. These are and-on cords, right? And so if somebody sees a problem in a line worker, they can pull the and-on cord, and what will happen is someone will come forward and say, oh, I see you pulled the cord. What's wrong? And they'll kind of swarm on the problem. There's an interesting story. There was a joint venture between Toyota and GM at a plant actually near San Francisco in Fremont, California, and this was a number of years ago. But they took the Toyota production techniques, but they had American management. So they had an andon cord, and one of the American line workers pulled the andon cord. And do you know what happened? The manager came over and said, "Why did you pull the cord?" What did that manager teach that person to do or never do ever again? Right. And also every person that saw that interaction, never pull that cord, right? So that's sort of an example of if stopping the line is a bit of a privilege. Forgetting to dampen failure where possible. There's a bunch of examples with the chaos days, and Russ talked about them this morning. So I don't really need to go through them, but you don't just do chaos days and woo, have fun. There's a way to sort of dampen it and do practice for actual failure in a way that is sustainable and not super painful. Another landmine, only reviewing failure. Do you ever have a postmortem about why the site is up? Right? It's interesting in our industry. So here's an example of this, right? You kind of see, that landing looks a little bit kind of weird, but it worked out, so all right, cool. And then we do this all the time. Okay, well, that worked out, so maybe we'll push our system a little better or a little further, and it's a little bad at the end there, but okay, made it down, great. This pilot got themselves, this I believe was either Frankfurt or Munich, actually. Yeah, Hamburg. Okay, yeah, but scraped the wingtip off the runway. Okay, well, but they didn't crash, so all right. And then we've got this, right? Sunny day, this is in California, lined up on the runway and right at the end there. Now, I doubt any of you want to be on any of these planes, but which one got the postmortem? This one. Well, that one, yes, they did get a postmortem as well. But this one got a lot of attention because of the wing falling off. Yeah. Or the elevator falling off. So it turns out that you learn as much from studying successes of your organization as you do the failures. In fact, in some ways, you might learn more, which is an interesting thing to think about. So forgetting about bias, another landmine. If you wanted to know whether or not the plane landed at the beginning, that's outcome bias, right? And the video that we just saw, another example of outcome bias. We judge an event by the outcome, right? That last landing was, in our minds, worse than all the others because of the outcome, even though the others probably weren't that great, especially if you're on board. That's outcome bias, and our brain is just kind of full of bias. We're going to talk a little bit about that. Hindsight bias, that's with knowledge of the present, past decisions were clearly poor. And I kind of think about this like a time machine. Like if you had a time machine, you could go back and you're sitting at your desk and you could come up to you and you're like, hey, you're about to type drop table. You really sure you want to be doing that? And you're going to be like, yes, at this point in my life, failure seems very implausible. And then you do it and then you're like, oh, shouldn't have done that, right? But we only ask that question because we have the knowledge of the future. So the reason we would ask it is because we know the outcome and we have hindsight now to look back on the event. You see this a lot in retrospectives. If somebody ever asks you, why didn't you notice or you should have done X, those are all hindsight bias questions. The only reason you're asking them is because you are in the future and you can look with hindsight and have a different perspective on it. Correspondence bias, I like to call this the quintessential DevOps bias. So this is undue emphasis on internal characteristics to explain someone else's behavior in a given situation, right? So here's the thing, right? We saw this picture, I want change, I want stability. They're smiling. And like the second they have to talk to each other, huge frowny faces, right? Because on the operations side, it's like, oh God, those developers, they just want to push code all the time. And they suck. They all suck, right? And the development people are like, I am tired of deploying to their crap running on CentOS 3. Can we use a modern version of CentOS, please? So the point here is that these people are angry at each other solely because they're developers or operations people, right? And this is something we're trying to fix with DevOps, but this is correspondence bias. Now, as humans, we are awash in a sea of biases. And this is I just went to Wikipedia and I just cut and paste, right? These are our brains are kind of horrible, right? By the way, a couple of my favorite biases on this, the IKEA effect. Do you know what that is? That is, we place more value on something that we built ourselves, even if it is factually, objectively crappier. So that bookshelf, the particle board, like we built it. So we're like, yes, even though there could be a really nice mahogany bookshelf. So no, this is better, right? Even though it's not really. The other one is the rhyme is reason effect. Do you know what that is? When whatever you say happens to rhyme, people will believe it more of the time. They've done studies, and they found this to be true, which is why, by the way, political slogans tend to either rhyme or be alliterative. It's the rhyme is reason effect. Bias is built into the way that our brains function. And actually, I'm going to play a clip from the Pulse here.
So what you have here is a sentence, a spoken sentence, that's been transformed by a computer to sound like gibberish. Any idea what they said?
No.
You can hear it one more time. Okay, now we'll hear the real sentence.
The Constitution Center is at the next stop.
Does it make sense that time?
Yeah, wait, was that the same?
It was the exact same sentence that you heard the first time.
No way.
It's the exact same sentence. Your brain is always using prior information to make sense of new information coming in. So once you know what the sentence is, when you go back and hear the distorted version, you can apply that information and it makes sense.
Isn't that wacky? It's almost kind of scary. So the point that I want to make is I'm not meaning to say that you can get bias out of your brain or out of our organizations, but you can be aware of it when it's happening, right? You can't get rid of it, but it's because it is built into the way that our brains function. Garbage in, garbage out. So we talked about this repeatedly. All I mean by this is if you're bad at incident response, you're probably going to be bad at retrospectives. And what I mean by that is if things are chaotic when the incident is happening, it's going to be very hard to do analysis later on that chaos because it was chaotic. And finally, deprioritizing retrospectives and learning processes. So what I mean by this is a lot of times when we have an incident, we might have an incident like on a Tuesday, right? And it was really bad, but we Band-Aided it and it was fine, right? Let's say actually it's on Wednesday. It works better that way. So we schedule the retro for Friday. We're going to do our retro on Friday. Friday comes around and that Band-Aid doesn't work anymore. It broke in the morning. So we spend the next 8 hours of our Friday fixing it. And at 5, when you have it fixed, we're not going to do a retro. We're going to go to the bar and try to forget about this whole thing. So we reschedule it for Monday. Well, Monday rolls around and it turns out the main engineer that helped us on that incident, they're on vacation. So, okay, well, they get back next week. We'll do it the week after. Turns out the Monday after is an all hands. So all day we're not available. So we schedule it for Thursday. So we're now 2.5, 3 weeks out, right? And the data that we have there is just useless. So you have to really prioritize this stuff. Now, as an example, what I like you to do now is take your timelines, compare with your partner. See what matches, see what doesn't match. We're going to take a couple minutes and do this. All right, one more minute. One more minute. All right, let's come back together. All right, so I have a question for all of you. Raise your hand if your timelines matched exactly. Yeah, okay, that's what I thought. But here's the thing, right? That incident was 45 minutes ago. And I told you at the beginning of it, I'm going to ask you questions about this. Now, how many people have incidents that go, hey, I'm going to ask you questions about it after I take your site down. So be ready for that, right? That never happens, right? So here's the point that I'm trying to make. If you do retros about 2 or 3 days after the incident, I guarantee you the substance of what you're talking about in the retrospective is all biased garbage. And it's not because people are trying to do that, but what happens is we think we have the data from our monitoring systems. We don't remember the nuance and the details of the context that we were thinking about when we were working that incident. So what we do is we take that data and our brain with its biases fills in the stuff we don't remember. And it does it so well, it does it without us knowing. So my assertion to you is if you do retros about 3 days after the incident, just don't bother. You're just wasting everybody's time. About one last quick question before I go into that, and then that's the last thing we're going to talk about. Who thought that this was difficult because it was aviation? Anyone? A few hands going up? Okay. That's totally valid. The reason that I use the aviation example is because most of us have gotten on an airplane and we sort of understand how flying works. Like we get on the plane, get a drink, and we go to sleep, and then we wake up in a new place, right? But if you look at the substance of the work that gets done to actually make that happen, I think we can say there's a lot going on there that we may not understand or may not be familiar with. But similarly, how often do we go into a retrospective with a notion of, well, I know how the database works. There's data in it and it's based. So I'm going to go in, right? And you're like, I know the database thing. They're screwing that up. Those people always screw that stuff up in the database, right? And we take that attitude to a retrospective when in reality, running databases at scale is hard. Right? Running operations at scale is hard. But if we aren't in that work, we might have a notion of what that's like and drag that into the retro. So it's just a reminder that a lot of this work is a lot harder than it might seem, even in systems that we're in and we think we're familiar with. All right, I want to close actually with the Rasmussen triangle here. Rasmussen was a guy that did a lot of work on 3 Mile Island, and he came up with this. And so you might think, like, why is this safety stuff? Why are incidents so hard? And he explained it in this model, which I really like. So it's a triangle. Obviously, it has different boundaries. Boundary of economic failure. What that basically says is if we went over that boundary, we wouldn't do it. It's too expensive. We wouldn't do the project. The business wouldn't pay for it because it's too expensive. Boundary of unacceptable workload. What that basically says is humans are lazy. I don't mean that as an insult, but we are, through evolution, we try to get the most amount of work done per unit of sugar that we burn in our brain, right? So we're going to try to do the laziest. We're going to get the most work done. We're going to try to find the workarounds that are most efficient for the job, whatever task we're doing. And this leaves then the boundary of functionally acceptable performance or acceptable risk. What happens when we go over this boundary, do you think? This is an accident or an incident, right? So this is what we got. So, in his model, in Rasmussen's model, he's got this idea of pressure gradients, right? Cheaper, better, faster. So the business is always pushing us this way. Cheaper, better, faster. I want whatever you do to be cheaper and better and faster. We've got us down in the trenches working, trying to do maximum work for least effort. Which boundary are we both pushing that system toward? Right? So he came up with this idea of the discretionary space, right? And what he said is that organizations that get really good at incident response and dealing with outages are allowed to explore the discretionary space. So it's not that Amazon and Netflix and Google and all of these companies are so much better at incident response than we could be. It's that they've built systems where their people can sense that we're going near the boundary much closer than we really want to be, and they can either pull the system back from crossing that boundary, or they're really good at the incident response, so if it goes over the edge, they can pull it back most of the time in a way that customers, us, don't even notice, right? So what might be an accident for us is an incident for them because they work on exploring this discretionary space and allowing their people to explore the space. We're a little bit over, so I'm going to rush through this last one because this is the last point, and then there's some takeaways, and then we can go drink beer. People heard of the S3 outage, yeah? That S3 outage that took everyone down on the East Coast. I pointed out that if you read the retro on it, they don't use the word human error once. And I think that's really important. So if you read the retro, what happened is an engineer typed a thing. He pulled some servers out of rotation on S3 to do a check, and he meant to type pull 3 servers out, and he typed pull 30. It was a typo, right? What they found in the aftermath of this is other input tools, other operational tools that didn't have a check. They didn't have, when they should have had a --force, yes, I really want to take S3 down option. And if they had, then you'd want to add that to a bunch of different tools. Service health dashboards, real dependencies. So Amazon has a service health dashboard, right? Except it was down because the service health dashboard uses S3. Oops. Index subsystems, insufficient partitioning due to growth. So what they found is they have an algorithm to repartition S3, right? But it turns out that US East 1 gets used a lot more than the other zones. So this algorithm wasn't tuned properly for S3 in the East zone, which gets a lot more use than the other S3 zones. And then finally, they had never restarted the system fully in years. Think about that. They'd never restarted the service fully, completely end-to-end, which this outage made them do, because they had to, because that's what went down, in years, right? So if Amazon had just called this human error and then just fired that engineer because that person sucks and is horrible and doesn't know what they're doing, they would have never have learned any of those lessons. None of them. They wouldn't have learned about how their system actually works or how engineers on the ground actually operate it. All right, here we go. Last 3 slides, takeaways. So what now? Takeaway number 1, the key to reframing failure is to stop thinking about incidents as events that went wrong and start thinking about them in terms of your team's response to them, right? Another way to say that, develop your incident immune system. It gets better the more you use it, just like ours. Takeaway number 2, to make this practical, your operations and infrastructure need to be what I call retrospective ready. Right? They need to facilitate retrospectives that we're going to have. And a lot of times they don't right now. And that's something we need to work on. Finally, takeaway number 3, the only thing that we directly control in the complex environments we operate in is our reactions. Right? We only really get to control what we do in response to an incident. Right? So that's what we need to focus on, is getting better at that. Let's go get some beer.